Dear students, in this video we will see transaction management of database management system. So specifically we will see what is a transaction, definition of a transaction, asset properties with a detailed example, so that you can write a complete answer, a long answer in the examination. Now, what is a transaction? A transaction refers to a collection of operations that perform a single logical unit of work. For example, if we are transferring money between bank accounts, for example, if we have a bank account having some initial balance and we want to transfer some, for example, $50 from account A to account B, right? So account A must be deducted $50. Like here we are having the example, account A must be deducted with $50 and it should be updated, and the account B should be added with $50 and the account B should also be updated. This unit of work, this complete unit of work is called a transaction. So we can say in simple, transaction is a unit of work, a logical unit of work in a database system. Example you can write as transferring money. So transaction, and it is very important in case of a DBMS. This plays a very crucial role or important role, so that the DBMS should always be efficient and consistent. That means that whatever data we are seeing in the database should be correct, right? So inconsistent data should not be shown to the user. So for example, sometimes a partial transaction may occur, that means account A is updated and the account B is not updated. At that time, the database system may result in an inconsistent state that should be avoided. Now, we will see a very important topic, that is asset properties of the transaction. So this topic is mostly asked in the examination, the semester examination. So we'll see asset properties means we have to remember the four things here: A for atomicity, C for consistency, I for isolation, and D for durability. So we will see in briefly first the definition, then we will see the example, how it will happen, how the database system manages these asset properties, right? To maintain the correctness of the database, to maintain the consistency of the database, these four asset properties must be satisfied for any transaction, right? So now, what is atomicity? Either all operations of the transactions are reflected properly in the database, or none are. That means if you are transferring, for example, if we take this example here, if we are here we are having the account A and we are having account B. Suppose account A is initially having $4,000 and account B is having initially how much? $5,000 in the database. Now you need to transfer from account A to account B how much? 50. So 50 will be deducted from A and it will be added to B. So at the end of the transaction, what should happen? So this should become 3,950. A should become 3,950 and B should become 5,050. So what is the meaning of atomicity here? Either this all operation should be done or none. That means it should not be the case that A is updated and B is not updated. So that should not happen in case of the database transaction. So that is what the atomicity means. So database either completes the operation or it will cancel the partially completed operation. So either all or none. So that is the meaning in detail. Now we have consistency. Execution of a transaction preserves the consistency of the database. So preserves the consistency of the database means, suppose if we are having here account A is how much initially I said, this is 5,000 and account B is how much? 4,000. Or we will see the same example here. Account A is having $4,000 and account B is having $5,000. Consistency means before the execution of the transaction, before the execution of this transaction T1, if A plus B is 4,000 plus 5,000, that is $9,000. At the end of the transaction, it should also show 9,000. Because when we are transferring $50 from A to B, right? So the amount is transferred. It is not decreased. It is decreased in one account, means it is increased in another account, right? So before the transaction T1 begins its execution, if the sum of A plus B, we can say example, sum of A plus B is 9,000. So at the end of the transaction, it is also should be 9,000. That is what we mean by consistency of the database. Now we will see the definition isolation. Even though multiple transactions may execute concurrently, right? There may be a case that in the database, 2 transactions may be happening, or in reality, several users are online at the same time. A user may be executing his transaction T1, another user may be executing transaction T2, another user may be T3 and so on. Isolation means separation. So even though multiple or many transactions may execute concurrently, that is at the same time, the database system ensures that each transaction is unaware of the transaction executing concurrently. That means it should not bother about the other transactions being executed at the same time. Isolation means the inconsistent values may happen during the transaction, right? For example, if we see this example here, same example, when account A is updated. So at this stage, write A means what? Account A is updated. So initially what is A? 4,000. Now at this stage, what is the value of A? That is 3,950. That means account A is updated. Now, during this time, it's another transaction T2. What is the job of T2? T2 is another user. He is trying to do A plus B and show on the screen. Right. A plus B means what is the value of A he will get at this stage. If he access at this stage, what is the value of A he will get? 3,950. Since B is not yet updated, what is the value of B he will get? 5,000. So total how much? It will display 8,950. Actually it is how much? It should be 9,000, because when you add 4,000 and 5,000, it should be 9,000. Since if the transaction T2 is allowed to access the value of A during the transaction or in the middle of the transaction, so it will show inconsistent value, that is 8,950. So that should not happen. That should not happen. So the third property here, isolation, what it means, even though multiple transactions, many transactions are happening or simultaneously executing at the database, it is the job of the database system to ensure that one transaction is unaware. That means unaware means it should execute in such a way that they are concurrently executing. That is one after the another. In a serializable manner they are executing. It should happen in that way. Right. Now the fourth property. What is the fourth property? Durability. After a transaction completes successfully, the changes it is made to the database persist even if there are system failures. That means, for example, if the transaction is done, right? At this stage, write B is done and the user has been issued a commit statement. That means the database system should display a message that the changes have been done. Right? The changes have been done. So once the user gets the message that the database is saved, right, then in case of any failure, the database should show consistent or correct values. So what is the meaning of this one? That it is the job of the database system. It is the job of the database system that the durability should persist or continues even if there are some failures happen, because the user has been shown the message that the database is committed or saved, the changes have been saved. Then if there is any failure, then it should not affect the values of the database. So this is about the durability. Now, whatever I have explained, the detailed notes is given here. Atomicity means it is the job of the recovery subsystem. There are several components in the database system. Database system is a software, right? It has many subcomponents or subsystems available. So it is the job of the recovery system to ensure atomicity, right? Secondly, we have consistency. It is the job of the application programmer to ensure that the correct values are shown to the database. Isolation means it is the job of the concurrency control system. What is concurrency control system? It is a component or subsystem of the database system. Database system is a very large software. It is subsystem or part of the database system which is known as the concurrency control system that will ensure that isolation property takes place successfully. Now we are having the fourth one. What is that? Durability. So durability is handled by recovery system. This component of the subsystem, it ensures that the values persist or continues after the message shown to the user that the database has been saved. So these are the 4 properties a transaction must follow to ensure the correctness of the database. This is known as the asset properties. If you have any doubts in this topic, you can write in the comment section. Do subscribe, like and share this video so that I can upload many other topics very soon. Thanks for watching.